Okay. Get the pen reset here. So tonight we're going to do, like I said, 7.3, 7.4. 7.3 is addition and subtraction of radical, square root kind of things. And then the other one is on rationalizing, which I kind of mentioned a little bit about last week. So we're going to kind of use some of the same ideas with the simplifying stuff, okay? And remember I said something to you about how radicals are very kind of similar to fractions, okay, in the way that their operations are used on them. So let's go with addition and subtraction. Square roots and radicals. So, like with fractions, okay, when you add and subtract fractions, what do you got to have? Denominator. Got to have a common denominator, right? Okay. With radicals, okay, so if we have, say, this, all right, plus this, okay, we can't add those things because they're not common, all right? So the number inside, right, here and here, that would be like our common denominator in a fraction, okay? If they're not the same, we're not going to be able to add those, all right? So certainly, we talked about how, in a calculator, in a real-world situation, if you wanted to add those, you calculate them and get an answer. But in a simplifier or a mathematics situation, we can't add those unless they're common. Okay, that's the main idea behind adding and subtracting fractions. That those have got to be the same. So if we have this, then that we can do. Okay, so that would be like saying, well, I have 1 square root of 6 plus another 1 square root of 6. So that's going to give me 2 square roots of 6. So you see, it's very much like saying, oh, I'd have like 1 6 plus 1 6 give me 2 6 or whatever. Okay, so that's why, that same kind of idea is the same thing, whether it's fractions or square roots. I mean, it's similar. So let's just do some more here. So let's say we have 7 square roots of 3 plus 4 square roots of 3. Okay, and a lot of times, when I teach, math 60, and I talk about variables, I always tell students, hey, slow down and read it and understand what it is, because then when you say it, sometimes it's easier for you. So if I say this, 7 square roots of 3 plus 4 square roots of 3, what's that going to give us then? 11. Right, 11 square roots of 3. Okay, so by just slowing it down a little bit and saying it, if you're not sure, 7 square roots of 3 plus 4 square roots, well, that's going to be 11 square roots of 3. Okay, same idea. So 8 square roots of 15 plus 9 square roots of 15, what's that going to give us? 17 square root 15. Okay. Again, so slow it down if you need to. All right. These numbers got to be common. We can't add them or subtract them unless they're the same thing. So we can do a subtraction here. 12, say we have 12 square roots of 5 minus 3 square roots of 5 equals, it doesn't change, the rule is still the same. So how many square roots of 5 would we get there? 9, good. Okay, so all we're doing is just subtracting the numbers on the outside, basically keeping the numbers on the inside the same. So what happens, you know, when, let's say we take it a little different step here, we have this plus this. Okay, so now I have 5 square roots of 27 plus 2 square roots of 12, and you might say, well, you said we can't add those, and I did say that, but are these completely simplified? No. So see, again, it's sort of like a fraction. We want to reduce it down, okay, get it down to where it's in its reduced parts, and then we can work with it. So here we've got the square root of 27, right? So, you know, last week we had all these guys written out. Okay, all the way down, right? So what's the largest one that's going to go into 27? 9 goes in there how many times? 3. So what's this going to look like then?
It's going to be a 3.
So 3 is going to come out, right?
Yeah.
Go to that 5. So we're going to get 3 times 5, 15. So we're going to have 15 square roots of 3. Okay, this 3 is going to stay. Plus, let's reduce this one down and see what happens. 4 and 3. All right, so what's going to happen here then?
It'll be 2 times 2.
2 times 2, so that's
4.
4 square roots of 3. Hey, how about that? Now we can add them, okay? So before we jump into a conclusion here and not say, well, they're not the same, we always want to make sure that they are simplified down first. And now we can do this. (19 square roots of 3). All right. So break it down first. All right, and then go ahead and add them. Now, if they can't be added, all right, then they can't be added. All right, there's some possibilities where we can have some that wouldn't be able to, where we're not going to be able to combine everything. So let's look at oops. Blanking out here. There we go. Okay, let's try this one out and see what happens. Okay, so what about this? Now, obviously, you know, we got to simplify these things first before we can do anything. So 72, what's the largest one that's going to go into there? 36 is going to go in there. 2 times, good. Okay. So then, what's this going to change to? So square root of 36 is? 6 is going to come out. 12. 12 square root of 2, good. Plus, what about the 20? Can we break that one down? 4 and 5, good. Okay. What's this going to turn out to be? So the 2 is going to come out. So 6 square roots of 5. Okay. What about this one? 9 and 5. Okay. So what's this going to turn out to be here?
-6.
Minus 6 square roots of 5. Okay, so now that we got it all simplified, right? Oh, look at that. So then what happens? What can we combine here?
We can eliminate
Yeah, what's going to go away?
6 square root of 5.
Yeah, these things, right? But see, we can't do anything with that, right? So, okay, so then this is just going to be 12 square roots of 2. Okay, so even if we had had any square roots of 5 left over, I didn't choose a very good number there for 3. We couldn't combine them, okay? They have to be the same in order to combine them. So we get 12 square roots of 2. But the whole thing is you're going to want to simplify, okay, all right, before you start adding them. Now, obviously, some of them aren't going to be able to simplify, like those ones in the beginning I showed you. Okay, so then, you know, if you can add them, add them. If not, then don't. Okay, questions on that part? Okay, so let's take it up with us a little bit more. All right. So let's say we have this, and this, and this. Okay? So now we have a square root of 3 times the square root of 7 plus square root of 5 in parentheses. And so we think back, well, what did we do with this kind of situation before? So what did we end up doing with this? Yeah, we're going to multiply it, right? So you just distribute it inside. Okay, distribute that inside. What are we going to end up with? Square root of 21, good, plus square root of 15, good. Okay. Let's see, can we simplify those at all? Can we break them down? Anything going to 21? No, none of our square roots going to 21. What about 15? Anything going in there? Mm-mm. Okay. So can we add these then? No, they're not common. We leave them alone. All right, that's it. All right, can't break them down. Can't add them. We're done. All right, so let's look at one like this. All right, so now, yeah, man, I put another set of parentheses in there, made it a little bit harder. But think about what you have done before with this. Okay, what would we have done before with that if we didn't have those square roots there and we had some variables or something? FOIL, right? Okay. So guess what? That's what you're going to do. You're just going to FOIL it. Okay. So let's FOIL this. Here we go. Here, 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 here. Okay, so let's go ahead and FOIL. So 2 and 4, that's going to give us my 8. Now when we multiply these two, what's that going to give us? 2 square roots of 3, good. What about here on the inside? Okay, negative 4 square roots of 3, good. Okay, now let's think about this one. Okay, so we got a square root of 3 times the square root of 3. Okay, so we can think of that in a couple different ways. What is the square root of 3 times the square root of 3? It'd be 3, right? Now, remember I said you can think of that in a couple different ways. Okay, so you can think of that as 3, all right? Or you can think of that as the square root of 9, okay? Which is also, square root of 9 is 3, okay? So how you want to think about, I've told you all along, you got to find your way that you understand it. So if you take the square root of 3 times the square root of 3, that's the square root of 9. Square root of 9 becomes 3. All right? Yeah, negative 3, sorry. Negative 3, okay? Or square root times the square root. Okay, that's like the square root squared, so they undo themselves. Okay, and I don't know if that's kind of how you were thinking it. The people said 3, or whether you just figured that square root of 9 is 3. All right, I'm not sure, but somehow you got it. So now we got to simplify this thing. So let's look at our commons. So what is this going to give us? 5, right? Good. And then the stuff in the middle? Minus 2 square roots of 3. Good. Okay. So most of the time, just like with all those other FOIL problems that we were doing, I said, you know, almost every single time the stuff in the middle is going to combine, right? Same thing's going to happen here. Not every time, but most of the time. So you got to kind of look for that. Okay, so let's try another one. So again, we're going to FOIL here, 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 here. 2. So what are we going to get? Let's just step through this. So 10, right? Good. How about right here, these two? Good. 4 square roots of 5. Good. All right. And then what about right here? 5 square roots of 5. Good. And now, so here, let's think about this one, okay? So we got a square root of 5 times the square root of 5. It's going to give us square root of 25, which is 5, right? Okay. And then I got a 2 hanging out here with it. So the 2 times the 5 gives us a 10, so there's quite a bit there. All right, so square root of 5 times square root of 5, square root of 25. There's a 2 out in front. Square root of 25 is 5. Goes with that 2. And this time I got the negative right. All right, so again, I look inside to see, right, what I can do inside, and then here I have these. All right, and today for some reason things I'm making up is canceling out. If I tried to get something to cancel out, it wouldn't. So 10s are gone. What do we get on the inside? 1 square root of 5. All right. So we're just foiling, okay? Just foiling when you see this stuff. Let's try another one here. All right, so let's try one like this. Okay, now we got square roots all over the place. Just got to work through. Again, we're foiling. Okay, so let's step through it. So, what do we get on the, what's our first term going to be? Well, let's take a look at it, right? So we got a square root of 2 times the square root of 2. What's that? Square root of 4, which is 2, okay? But I got a 3 hanging out here with it. So that's going to be 6. All right, so square root of 2 times square root of 2 gives me 2. 2 times 3 is 6. That's going to go there. All right, now I got to do this one. So this is going to be square root of 2, square root of 6, 12. So I'm going to get 3 square roots of 12. Okay, got that one done. Now let's work on these inside ones. So I'm going to get 3 square root of 12. Look at that, they canceled out again. I'm really not trying to get this to happen. And what do I got here? Minus. So I got a square root of 6 times the square root of 6, which is
36.
square root of 36, which is 6, right? But I got a 3 hanging out there, so 18, good. All right, like I said, those are going to cancel out. Give us a negative 12. Crazy. But you're just foiling, all right? So it's not really much different. Just trying to keep everything separate. All right, let's do square root of 2 times 3 minus the square root of 2. Okay, let's try these ones. Okay, again, we're foiling. So we get here, 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 and here. All right, so 3 times 3, that's, what are we going to get here? 9. Okay, and then this one here is going to give me minus 3 square roots of 2, and then here plus 3 square roots of 2, good. And then our last one, we're going to get minus 2. Okay, now actually this time I did intend for these to cancel out. Okay, I wasn't just getting lucky there. So we got those to cancel out, and I'm left with these. Here, let me use some colors here. Okay, all right, so now I have 9 minus 2, which is 7. Okay, these special situations are called conjugates. So if we have something like this, a plus the square root of b, okay, or it could be a b, and a minus the square root of b, then those are called conjugates because the plus and the minus are different. Okay, so for those you are taking 95, I believe it is. I can't quite remember if we do this in chapter 9 or not, but you'll see this again and it'll be important. Okay, so I'm not gonna ask you on your test, you know, hey, give me the conjugate of this, because we're gonna apply it here in a little bit. But you know, it's good if you kind of recognize that a little bit, so you can see how these conjugates work. Okay, so if I have 2 plus the square root of 5, then the conjugate is going to be 2 minus the square root of 5. If we have 3 minus the square root of 3, then the conjugate is going to be 3 plus the square root of 3. So we're switching this sign here and here. Okay, those are your conjugates. Now something happens, and if you think about it, you'll say, oh yeah, this makes sense. If we take, like I did up there, so let's go say 6, so I kind of change it up a little bit, and we multiply, so there's 2 conjugates, right? So if we multiply these by foiling, what's our line going to be? What are we going to have down here? 25 plus 5 square root of 6, good, keep going. Minus 5 square root of 6, good, keep going, we're doing great. Square root of 36, right? Is going to be 6. So, what happens to our numbers in the middle here? They drop, they cancel, huh? How come they're canceling? Yeah, because of plus and minus, okay? So if we have conjugates, that's what's going to happen, okay? Those things are always going to cancel. They're going to go away, all right? So the only thing you have to worry about is the two things, you know, here, here, and these two, all right? So I don't think, you know, again, I don't think it's a great of an idea. I get kind of concerned when you get so much stuff thrown at you, and they say, hey, this is a conjugate. You don't have to multiply these two, and you get to a test and you go, oh crap, I can't remember if that's a conjugate or not. Just foil it, okay? And don't worry about it. And if the things fall out, then they do, okay? But I think it's good that you can kind of recognize it, that that is a conjugate, or because what we're going to do when we do some rationalizing, we're going to use conjugates. So I think it's a good thing that you kind of know have a little bit of a feeling for what a conjugate is and kind of how it works. But you know, when you're taking a test or something like that, just foil it just to be safe. Okay, that would be my thing. But you can, you know, again, that's whatever works for you. Okay, I'm going to look through here and see if there's anything I see. They write a conjugate like this too. I have one like this I see in the assignment. All right. So, you know, that's considered a conjugate because, again, it's like this. Okay? And these two guys are the same. So, I haven't seen too many conjugates written like that. Usually it's the square root is last, but he does have it in there. But you, again, just foil it. Okay, make your life easy. Okay. Oops. Square root of 13 times the square root of 13, what's that going to give us? Square root of 13 times the square root of 13? 169, but what's the square root of 169 going to be? 13, right? Okay, that square root's going to go away. Square root times the square root kind of undo themselves. All right, and then we'd have the 5 square roots of 13 here. Okay, and the minus 5 square roots of 13 there. They're going to drop out. And then we just put those together, okay? So I did see that he's got a couple like that. Oh, here's some too. I see he's got some stuff written like this. And again, you guys get a chance to practice some of these. So we have something like this. Squared. All right. So, you know, thinking back a little bit, you know, how did we handle this before when we had variables? What did we do with those? Did what? Write it twice. That's awesome. You remembered that. Good job. So we're going to write it twice. Okay. And then now you just foil it. Okay. So we got this, and this. Okay, so we're going to foil this. So what's this? What's our second line going to look like here? 2, because the square root of that's 4, right? So that's 2. Okay, plus square root of 6, good, because we're multiplying. Plus square root of 6, good, because we're multiplying. Plus square root of 3 times the square root of 3. And then we just combine it. I'm looking at some other stuff on here, and I think we covered any. Do you have any questions about anything? Do you see anything on page 502 that you're not real sure about, I mean, obviously I'm going to give you a chance to practice some stuff, but if there's something that right now you're thinking, oh, there's just no way I could even try that one. 502.
14.
14.
Do we have to go up that far? No.
Well, that's okay.
Or 10. How about that?
Whatever you want. Okay? So as long as our, whatever we're adding here is the same, we're good to go. Or subtracting in this case. They're both y's. So what do you think this is going to give us? Negative what? 20 square roots of y. Yep. Good job. Don't let the variable throw you. The idea is still the same. Good job. Anything else? Okay. So let's move into 7.4 here. We'll see how far we get through before we'll try to get through. Oh, I think we can. We'll go very close. We'll see what happens. So in 7.4, we're going to take a look at something called rationalizing. Okay? So basically the idea is, and we talked about this a little bit last week, how you cannot have a square root or a radical in the bottom of a fraction. Okay, you know, it's just one of those laws of mathematics. You can't have one. Okay, so what we want to do then is we need to get rid of that, and the process of doing that is called rationalizing the denominator, basically. So if we start out with something like this, over the square root of 6, okay, and we want to rationalize that because there's a square root down here. Can't have one. Got to get rid of that. Okay. Basically, all we're going to do is just multiply by that square root of 6. Okay, because what happens when we take the square root of 6 times the square root of 6? What are we going to get now? 6. Okay. All right. And what are we going to get on the top? 2 square roots of 6. Okay. So first of all, why can we do this? Well, because this is the same as 1. So you can take any number and multiply by 1 and not change anything. All right, square root of 6 over square root of 6 is 1. So that's okay to do that. All right, and now we've got this where we can reduce that. Right, square root of 6 over 3. Okay. So we're rationalizing because we're taking this down and we're making it a rational number. So we're taking the bottom and we're changing it so it becomes a rational number. All right. In this case, it's an integer. It's our whole number. It's 3. Okay. So we're multiplying by that square root to do that. And the whole idea is because if we multiply these two things, we know the square roots are going to go away, and we're going to get 6. Okay, so it's not, that's the concept behind it. All right? But you need to check because there's a lot of times where this is going to reduce. Okay? So remember I said, you know, when it says simplify, you really got to be careful that you have, you know, your radicals simplified. Okay, reduced down, just like if it was a fraction. You got to make sure they're simplified. So don't get caught in doing the rationalization and then not checking. So if we have 10 over the square root of 8, All right, and there's a couple ways to do this. All right. So we've got this situation here. All right. We can't reduce the 10 and the 8 because the 8 is underneath the square root sign, so we can't reduce that. So we're just going to rationalize it. All right, so what would we multiply the top and bottom by? Square root of 8, right? Good. So what are we going to get on the bottom? That's an easy one. We're just going to get 8. What are we going to get on the top? 10 square roots of 8. Okay? Now, a couple things can happen here, right? Because, like I said, we can reduce this. Okay? We can reduce that. And what else can we reduce in this thing? We can reduce that. Okay? So there's a couple things happening here. All right, so we can reduce this, and we can reduce the fraction. And again, it doesn't. I guess it kind of doesn't make a whole lot of difference which one we want to do first. All right? It's kind of up to you. So I think what I would do, I think what I feel like I want to do here is, let's get reduce the fraction first. So let's see, this is going to be a 5 square roots of 8 over 4. So I got that. Okay, now I think I'll break this down. So that 8's going to break down to, yeah, 2 and a 4, right? And then the 4 is going to come out. Okay, so 4 and 2, 4 is going to come out. What's going to happen right here? So this breaks down to 4 and 2. Square root of 4 is 2, so that's going to become 10. And we're right back to where I started from. Over 4, and then we can reduce it again. Okay, now I got to be careful because I can't reduce these two things because even though they're both 2's and we'd like to cancel them out, and I've seen that happen, that's underneath the radical, so you just, hey, I got to leave it alone. Got to leave it alone, okay? And if we would have said, hey, you know what I think I'm going to do here first is break this down. I could have broke this down to 4 and 2. Took that square root of 4, brought it out here, multiplied it by the 10. It was 20, but we end up getting the same answer. Okay, so it doesn't make any difference. It's kind of the way you want to handle it. All right? So in this situation, we could have went this way. I don't want to try to confuse you too much, because this could have been handled a couple different ways. We could have broke this down right here, took the square root of 4, that would have come out, multiplied with that 10, and then we would have got the same answer. All right, just a different path. And another thing we could have did, even to confuse you even more, is we could have broke this thing down here and then rationalized it. So you see there's a couple of different ways you can approach it. All right, and I don't really know if there's a preferred way. You just got to find the way you want to do it, you like it, and it works for you. All right. It kind of depends on the situation, but I think for most of your cases, you're pretty safe just to go ahead and just multiply by that square root of 8 and then see where it takes you. Okay. But that's kind of a preference thing. You can do it either way. Let's see, we might have something like this. So we would rewrite that since we can't reduce it, so it looks like this. Okay, so now we got a square root top and bottom. But we're not too worried about the top, we're just worried about the bottom. The bottom's the one we got to rationalize. So what would we multiply the bottom one by? Okay, and then we got to multiply the top by that too, because it's got to be the same. So what are we going to get on the bottom now? 2, and what are we going to get on the top? Square root of 10. So then I just double check. Okay, can I break this 10 down? Always want to check that. Can we break the 10 down? No. Okay, I can't reduce it even though it's a 2 and a 10. By gosh, I'd sure like to, because I've done a whole bunch of problems like that previously. But you can't, because this is a square root of 10, and that's a different thing. Okay, so that one's done. So if you see something like this, you're just going to break it into 2 square roots and just rationalize it. Any questions thus far on what we're doing here? Okay, let's do one more. Okay, so here's another one like this. So again, we have different routes we can take. All right, we can simplify this first, and let me just show you what that does, because you might like it better. So what does the 12? What is that 12 going to break down into? Break down to what?
4 and 3.
4 and 3. Okay. So that means we're going to have 6 over what now we're going to have in the bottom now? 2 square root of 3. Okay. We see here, yeah, that can be reduced. Three square roots of 3, but nope, can't have that. And what's going to be on the bottom?
3.
Oh, look at that. That reduces. So that would be breaking it down first. So is that easier? Well, let's take a look and see what it looks like the other way. Multiplying by this, top and bottom. 6 square roots of 12 over 12. Oh, but that reduces. Look at that. But now the 12 can be simplified, and since we just did it up there, 4 and 3, so it'd be 2 square roots of 3 over 2, and then that breaks down. Okay, so we're getting the same answer. So I don't know if it makes a whole lot of difference stepwise. Maybe it's do more this way, but again, I think you just kind of, find your way that you like to do it and do them that way. Because, whatever makes it more successful and easier for you. Okay, let's do this and then get you on a break, and we'll see how some more of these go here. All right. So let's say we have something like this, and we're going to rationalize this. Okay. I didn't give you too many of these, but I'll just show you how to do them, because I know I know we did this in Math 95, so. Okay, so here's an example of where we're going to use that conjugate. Okay, so when you're going to rationalize here, so what's the conjugate of that 1 minus square root of 3? Yeah, 1 plus the square root of 3, good. Okay, so here's a nice example where we're going to do that. All right, so let's work on the bottom. Okay, all right, so we're going to FOIL this. So obviously I'm going to get 1 and 1. And then what happens to these ones in the middle? I take 1 plus the square root of 3, 1 minus the square root of 3. And then what about these two multiplied together? What's that going to give us? 3, right? But again, because it's a conjugate, what's going to happen to the stuff in the middle? It's going to go away. Okay? And see that, again, that's why you multiply by that conjugate, is because you don't have any more square roots on the bottom. Okay? Because that's your objective, is to get rid of those things. So if we multiply by the conjugate, it goes away. The middle stuff goes away. And now we just got to do the top. So we just distribute that, and we end up with this thing here. Okay? And you might think, oh, I'm done. Yay. But things are going to reduce. Okay? And that happens a lot on these types of problems, is that these things are going to reduce. So that's going to give me a negative 1 there, minus the square root of 3. Okay? So that's where we use the conjugate, is in that. And I know for you guys that are taking 95, I remember doing this in 95, because I remember asking them something about, they said they saw this in 65. So yeah, really? Huh. So maybe I'll just give you a couple of those to do for practice, and then just so you kind of see it, so when you get to 95 you can say, yeah, I did a couple of those. Any questions on rationalizing? I see also that we have a supplement today we got to go through too. So we'll probably do that after break. Okay, so take about 5-10 minutes. We'll come back. We'll look at the supplement, do a couple more rationalizers, and then I'll give you a chance to play with some too. Oh, and one other thing, grades. I got my spreadsheet. We can do that too if you want to see what those are. Everything should be pretty much up to date. Okay, so it'll take me a few minutes to load it up, but you want to ask me before you leave tonight, I can do it.
We all grow up, man.
Yeah,
Fast.
you know, when we get old, man.
I'm too old and broken to really go out and compete in that. I'm pretty. I wrecked my career under pretty bad about. Oh gosh, man, it's been almost 12 years ago. It was a life changer. Wow. I was in a coma and I was 223 fractures.
Oh.
Brain
Didn't mess up your
surgery.
back, right?
What's that?
Didn't mess up your back when you were still.
Oh, dude, I crushed my skull.
Oh, my.
Did a emergency brain surgery. They're pulling shards of bone out of my brain.
Wow. That took a turn. No pun intended.
I'm just saying, like, risk to reward factor anymore.
This is getting recorded.
No, I'm so glad we recorded this whole thing.
I didn't get all of it.
I'm not running for president.
Okay. I have nothing to say to that. Okay.
My name's Fletch, buddy.
Let's get back to this though. So just one more rationalization one here. Just again, so this is your 2 plus square root of 6. That's your conjugate. 2 minus square root of 6. Okay. So let's work on the bottom. So what are we going to get on the bottom here? Let's work that out. They're conjugates, so 4, right? Okay, and then what's going to happen to the square root of 6's? They're going to cancel because it's a conjugate. So really all we need to worry about is these two here, okay, and these two here. But you can FOIL it, certainly. It doesn't make any difference because it's all going to come out in the wash. So we're going to get a minus, and then square root of 6 times the square root of 6. 6. Okay, so there's that. So the bottom's done. All right, now we're going to work on the top. So we move that inside. So what are we going to get on the top here? 14 minus 7 square root of 6. Okay, so that's done. And how about that? Now in this case, the 2 doesn't go into, goes into here, but doesn't go into the 7. All right, so you can actually leave it alone. You're not gaining anything by putting that 2 into there. All right, so we're just going to leave this one alone. Okay. But there's one, like I said, I just wanted to show you another one of those. All right, and then when we do our practice, I'll probably toss one of them in there. Just like I said, I know you do it at 95. It'd be nice if you just had a little bit of background in it. It doesn't look like I gave you any. Let's see. Taking a look at this supplement, way back on page S30. There's really not much to this, okay? They used to have some pretty decent supplements to square roots, but maybe there's someplace else. I can't remember where they're at, but you know, this one here says, again, you don't have to write this down. I'm just going to go through it. A student correctly solved an equation and ended up with the solution 30 square root 12. However, the answer in the back of the book was 5 square root 3. So it says round both numbers, to the nearest tenth using your calculator. All right, so then if we wanted to change this using a calculator, I'd probably use Desmos before I'd use my calculator, but I'll just do this real quick. So let's see if I can do it. 30 divided by parentheses, I think it's 12 square root parentheses equals 8.66. Alright, so I just took 30 divided by the square root of 12 basically. Now I'm going to take 5 times the square root of 3. Clear that out. 5 times square root. No, I got it. So 5 times 3 square root equals 8.6. How about that? They're the same. Okay. No big, because they are. Show how these answers are the same algebraically. So if we took this here, all right, we got to rationalize it. So what are we going to multiply it by? Square root of 12, good. Top and bottom, because it's got to be multiplied by the same thing. 30 square root of 12 on the top. What are we going to get on the bottom? 12. That's why it's rationalized. Good. Good, good, good. Okay. Hey, we can reduce this a couple different ways. Okay, see here again we could have broken the 12 down, but I just went ahead and did it. So let's reduce this guy up. What's that going to reduce to? What goes into 30 and 12? So what goes into 30 and 12? 6 does. Great. So that's going to give us 5 on the outside there. And 2 there. Now this 12 can be reduced down though. Right, 4 and 3. Square root of 4 is 2. That's going to pop out there. Actually, the 2 that we're bringing out can cancel with this 2, and we just be with 5, left with 5 square root of 3, which is what they said we should have got anyway. Okay. So that's the supplement. I don't know what the big deal was with that. But I did it, because they told me to do it, so I did it. All right. So let me give you some to work on. Okay, some people come up and ask you about their grades. You want to do that, you can. Do you have anything about the test also if you want to ask me? You know, anything's fair game. You can ask. I don't know much about the movie Fear and Loathing in Las Vegas, so I can't answer any questions about that. It's I didn't watch that one. I've heard of it though.
One of the tests, are you going to test us on that, the trinomial thing where you have, it's the difference between two cubes?
No, there's no cube stuff on there. Nope. It, if it is like this though, like that, okay, that's fair game because if you take an x out of there, okay, and then that's the difference of two squares, right? Okay, the ones you won't see are ones like this. That's the sum or difference of two cubes. And you use that formula. I said I wouldn't, so I don't put those on. I lost my thought here. Sorry. Okay, let's do this one. Actually, I like this one. They didn't really dig many of these, and I'm not exactly sure why they didn't. Here's that one. Only 6. That's not too bad. All right, try those ones out. Okay, if you have questions about anything, pop up. I think this is